where a lot of things is just Cauchy-Schwarz. Yes,
mathematics
is basically Fubinian Cauchy-Schwarz.
When you understood this, of course, you needed it for Erde stone, let's say, or for a particular concrete reason. But at least I guess it was clear that it's an enormously powerful tool. That every graph can be,
Then I realized it didn't take too much time to realize that it can be applied here or there. But I was just a graph theorist, and still mostly I am just a graph theorist. So, but in graph theory, in extremal graph theory, then I realized that it is powerful. And then it happened to be the case that this or the modification of it, generalization are even more powerful in many areas, like in theoretical computer science. But to my great surprise, actually, they apply it in biology and neuroscience in Hungary. I don't know how, but because that is a graph and some connections, and they break it into things which...
I mean, you just said that Cauchy-Schwarz is applied everywhere, and so maybe it's universal. I think the regularity lemma is an extremely universal. I mean, so this it says much strongly, I think, that in a completely unorganized system there is a very strong sense of order. Order in the sense that things are random or look random, but random, like you said, means we know we'll find what we expect as frequently as we expect it in a random graph. So it's not, I think to me, and I think to combinatorics in general, this was the first major technique that exists. So there are lots of techniques or lots of methods used in combinatorics, but this was one of the first big hammers or universal tools that whenever you were faced with any problem, the first thing you'd say to yourself, wait a minute, let's assume that we partition it into regular pairs and then we work on them because they are much nicer.